Firstly, the existing load calculation involves several components. Pedicure spas consume 6 times 8.2 amps times 120 volts, totaling 6,120 volt amps. Makeup and exhaust fans, rated at 2 times 0.75 horsepower, equate to 1,500 volt amps. The water heater consumes 10,000 watts, equivalent to 10,000 volt amps. The dryer consumes 6,500 watts, or 6,500 volt amps. Fluorescent fixtures draw 13 times 3 times 1.2 amps times 120 volts, amounting to 4,680 volt amps. Therefore, the total existing load sums up to 28,700 volt amps. Secondly, there aren't any added loads specified. Consequently, the total load with added load remains at 28,700 volt amps. The existing transformer is rated for 15 kVA, which is insufficient for the existing load and the total load that has been calculated. A 25 kVA transformer would be appropriate. Thirdly, the existing 125 amps of 480 volts primary feed is sufficient for the larger transformer. Fourthly, the secondary feed of the existing transformer is not specified. It is potentially too small for the increased load. It will be necessary to confirm the secondary feed size with the existing transformer information or consult with an electrician. If the secondary feed is not adequate, it will need to be upgraded to a larger size. In conclusion, to accommodate the total calculated load, the existing transformer should be replaced with a 25 kVA transformer. Also, the secondary feed needs verification and potential upgrade if necessary. When calculating electrical loads for commercial spaces, particularly those with specialized equipment like spas, it's crucial to accurately assess the power demands of each component. This includes lighting, heating, ventilation, and any equipment used for specific services such as pedicure stations or makeup areas. The process typically involves summing up the volt, ampere, or wattage ratings of all electrical devices to determine the total load. Several factors must be considered. Firstly is the continuous load, which refers to the load that operates for 3 hours or more continuously. The National Electrical Code (NEC) requires that branch circuits and feeders supplying continuous loads be derated to 80% of their capacity. This means that the calculated load should not exceed 80% of the circuit or feeder's rating. Secondly is the demand factor, which is a ratio of the maximum demand of a system or part of a system to the total connected load of the system or the part of the system under consideration. It is applied to non-continuous loads to account for the fact that not all loads will operate simultaneously at their maximum rating. The NEC provides tables of demand factors for various types of occupancies and equipment. Thirdly is the voltage drop, which is the decrease in voltage that occurs along a conductor due to its impedance and the current flowing through it. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The NEC recommends limiting voltage drop to 3% for branch circuits and 5% for feeders. Fourthly, regarding to the transformer sizing, once the total load has been calculated, a transformer can be selected that has a kVA rating equal to or greater than the calculated load. It's essential to consider future expansion when sizing a transformer, as adding more load later may require replacing the transformer. Transformers are typically rated in kVA, which stands for kilovolt amperes. kVA is a measure of the transformer's apparent power capacity. To determine the appropriate transformer size, firstly calculate the total load in volt amperes by summing the volt ampere ratings of all the loads that the transformer will serve. Secondly, apply any applicable demand factors to the non-continuous loads. Thirdly, divide the total volt amperes by 1000 to convert to kVA. Fourthly, select a transformer with a kVA rating equal to or greater than the calculated kVA. Fifthly, consider future expansion. It's always a good idea to select a transformer with some extra capacity to accommodate future load growth. When dealing with three-phase systems, the calculations are slightly different than for single-phase systems. The power in a three-phase system is given by the formula power equals square root of 3 times voltage times current times power factor. To calculate the load on a three-phase transformer, firstly, determine the line-to-line voltage of the system. Secondly, determine the current in each phase. Thirdly, calculate the apparent power in each phase using the formula apparent power equals voltage times current. Fourthly, calculate the total apparent power by multiplying the apparent power in each phase by 3. Fifthly, divide the total apparent power by 1000 to convert to kVA. Wiring and overcurrent protection is also important. The conductors that supply power to the loads must be sized to carry the calculated current. The NEC provides tables that specify the ampacity of different sizes and types of conductors. Overcurrent protection devices, such as circuit breakers or fuses, must be installed to protect the conductors from overload and short circuits. The size of the overcurrent protection device should be based on the ampacity of the conductor it is protecting. In addition to the general calculations, certain types of equipment may have specific requirements. For example, motors have special requirements for starting and overload protection. Heating equipment may have specific requirements for temperature control and over-temperature protection. Compliance with the National Electrical Code is also important. The NEC is a set of standards that governs the safe installation of electrical wiring and equipment. It's essential to comply with the NEC to ensure the safety of people and property. The NEC is updated every 3 years, so it's crucial to use the latest edition. It is also recommended to consult with a qualified electrician or electrical engineer to ensure that the electrical system is designed and installed correctly. Electrical work can be dangerous, and it's essential to take precautions to avoid electrical shock and other hazards. Here's a breakdown of factors affecting transformer selection. Firstly is the load requirements. The transformer must be able to supply the total load connected to it. This includes both the continuous load and the non-continuous load. Secondly is the voltage regulation. The transformer must be able to maintain a stable output voltage under varying load conditions. Voltage regulation is typically expressed as a percentage. Thirdly is the efficiency. The transformer should be efficient in converting electrical power from one voltage to another. Efficiency is typically expressed as a percentage. Fourthly is the impedance. The transformer's impedance affects the fault current that will flow in the event of a short circuit. Impedance is typically expressed as a percentage. Fifthly is the cooling method. Transformers generate heat during operation, so they must be cooled to prevent overheating. Common cooling methods include air cooling, oil cooling, and water cooling. Sixthly is the location. The transformer's location will affect its environmental conditions, such as temperature, humidity, and exposure to corrosive substances. Seventh is the applicable standards, which are standards such as the NEC and the National Electrical Manufacturers Association (NEMA). Regarding the primary and secondary feeds, firstly, the primary feed must be sized to supply the full load current of the transformer. The secondary feed must be sized to carry the load current on the secondary side of the transformer. The size of the primary and secondary conductors depends on the transformer's kVA rating and the system voltage. The NEC provides tables that specify the ampacity of different sizes and types of conductors. Regarding overcurrent protection, both the primary and secondary sides of the transformer must be protected by overcurrent protection devices. The primary overcurrent protection device protects the primary conductors and the transformer itself from overload and short circuits. The secondary overcurrent protection device protects the secondary conductors and the loads connected to the secondary side of the transformer. The size of the overcurrent protection devices should be based on the transformer's kVA rating and the system voltage. The NEC provides guidelines for selecting the appropriate overcurrent protection devices for transformers. When upgrading electrical services, it's important to consider the existing infrastructure and the available capacity. This includes the existing service entrance, the panel boards, and the wiring. It's also essential to coordinate the upgrade with the local utility company to ensure that the new service can be connected to the grid. When performing electrical work, it's essential to follow all safety precautions to avoid electrical shock and other hazards. This includes wearing appropriate personal protective equipment, such as gloves and safety glasses. It's also important to de-energize circuits before working on them and to verify that they are de-energized using a voltage tester. Electrical work should only be performed by qualified and licensed electricians. In commercial settings, it's essential to consider the specific requirements of the occupancy. For example, healthcare facilities have stringent requirements for emergency power systems and grounding. Restaurants have specific requirements for ventilation and cooking equipment. Retail stores have specific requirements for lighting and signage. It's essential to consult with the local building codes and the NEC to ensure that the electrical system meets all applicable requirements. Also to consider our energy efficiency measures. There are many ways to improve the energy efficiency of electrical systems. This includes using energy-efficient lighting, installing occupancy sensors, and using variable frequency drives for motors. It's also essential to properly maintain electrical equipment to ensure that it operates efficiently. When selecting electrical equipment, it's essential to choose products that are listed by a recognized testing laboratory, such as Underwriters Laboratories, AL. Listed products have been tested and certified to meet safety standards. It's also essential to choose products that are appropriate for the application and the environment. Power quality is another important consideration. Power quality refers to the characteristics of the electrical power supply, such as voltage stability, frequency stability, and harmonic distortion. Poor power quality can cause equipment to malfunction or operate inefficiently. It's essential to monitor power quality and to take steps to mitigate any problems. Grounding and bonding is also important. Grounding and bonding are essential for safety. Grounding provides a path for fault current to flow back to the source, which helps to protect people from electrical shock. Bonding connects all metal parts of the electrical system together to create a low impedance path for fault current. Surge protection is also important. Surge protection devices, SPDs, protect electrical equipment from voltage surges caused by lightning or other events. SPD should be installed at the service entrance and at sensitive electronic equipment. Preventive maintenance is also important. Regular preventive maintenance can help to prevent electrical problems and extend the life of electrical equipment. Preventive maintenance should include inspecting wiring, tightening connections, and testing over current protection devices. Documentation is also crucial. It's essential to maintain accurate documentation of the electrical system, including drawings, specifications, and maintenance records. This documentation can be helpful for troubleshooting problems and for planning future upgrades. Arc flash hazard analysis is also important. An arc flash is a dangerous electrical explosion that can occur when there is a fault in an electrical system. An arc flash hazard analysis is a study that identifies the potential arc flash hazards in an electrical system and determines the appropriate safety measures. Electrical safety training is another consideration. Electrical safety training is essential for all personnel who work on or near electrical equipment. Training should cover topics such as electrical hazards, safety procedures, and the use of personal protective equipment. Emergency procedures are also important. It's essential to have emergency procedures in place for dealing with electrical emergencies, such as power outages, electrical fires, and electrical shock. These procedures should be clearly documented and communicated to all personnel. Contractor selection is also important. When hiring an electrical contractor, it's essential to choose a qualified and licensed contractor with experience in the type of work that needs to be done. It's also essential to check the contractor's references and insurance coverage. Permitting and inspections are other considerations. Most electrical work requires a permit from the local building department. The building department will inspect the work to ensure that it complies with the building codes and the NEC. Cost estimating is also important. It's essential to obtain accurate cost estimates before starting any electrical work. The cost estimate should include the cost of materials, labor, and permits. Project management is also important. Electrical projects should be properly managed to ensure that they are completed on time and within budget. Project management should include planning, scheduling, and coordination of resources. Commissioning is also important. Commissioning is the process of verifying that an electrical system is installed correctly and that it operates as intended. Commissioning should be performed by a qualified commissioning agent. Continuous improvement is also important. Electrical systems should be continuously monitored and improved to ensure that they are operating safely and efficiently. Continuous improvement should include regular inspections, testing, and analysis of data. Therefore, these considerations ensure a safe and functional electrical system for the specific demands of this commercial space.